Okay, Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shahroz Abdullah and today we are going to discuss nuclear fission reaction. We have already discussed nuclear fission, right? Today we will discuss fission chain reaction. This is very important curve and it's very important diagram. Most of the time it comes in examination that define nuclear fission and discuss fission chain reaction with detailed diagram of it. It's a very large diagram. You have to draw in paper in horizontal form. Okay. Now, how to do with that? So, nuclear fission. If you remember in the previous topic, we have discussed nuclear fission was that process in which a parent nucleus or heavier nucleus converts itself into a lighter nuclei or nuclei of an intermediate size with release of 3 neutrons and large amount of energy. And okay, this was whole process of nuclear fission in which a parent nucleus was splitting into a daughter nuclei or lighter nuclei, and the process of splitting parent nucleus or heavier nucleus was falling slow moving neutrons on that, and it was then all the phenomena was taking place, and it was done in the previous lecture. In today's lecture we will discuss fission chain reaction. Look, fission chain reaction is an uncontrollable process, and sometimes like in lower scale we control it in atomic energy. We use boron rods to control that nuclear energy, and this is basically a very dangerous phenomena in which much amount of energy is produced, and how it is carried out, please understand. Look, this is same neutron we have. Look, this is same neutron we have. Okay, we have fallen this neutron on uranium 92 235 for time being, for a short period of time of 10 power minus 10 to minus 12, 10 power minus 12 seconds. This uranium is now converted to uranium 92 236. It's a very excited state. Now this uranium will convert itself into barium and krypton. Barium and krypton. This is barium and this is krypton, Kr. Now, barium with mass of 1, atomic number 56 and mass number 141, and krypton with atomic number 36 and mass number 92. Okay, and in this process 3 neutrons are ejected. In this process 3 neutrons are ejected. These are 3 neutrons ejected, and very mega amount of energy is released in this whole process. Now, these are 3 neutrons. Now, this neutron, and this neutron. Now this 3 neutron will fall on separate uranium 92 235 atoms, or you may say elements. For example, this uranium is then fallen on separate. This is fallen on separate uranium 92 235. This is fallen on separate uranium 235 92, and this is again fallen on uranium 92 235. Now for time being it becomes very excited with a static on that 92 236. Mass number will turn to 92 to 236. Okay, and this again 92 236. Again this will convert to uranium 92 236. Okay, this is highly unstable state, and now this will convert itself into the same daughter nuclei like parent, like daughter nuclei what we call barium and krypton. Look, this will be separated into barium and krypton. Okay, this will again separated into barium and krypton. Barium and krypton. This will again split into barium and krypton. Okay. Now, barium with mass of 141, atomic number 56. Similarly, krypton with mass number 92, atomic number 36. Barium with mass 141, atomic number 56. Similarly, over here 92 236, and similarly over here 141 and 56. Similarly with krypton over here 36, 92. Okay. Now again in this process 3 neutrons are ejected. Let me show those 3 neutrons over here. Okay, those 3 neutrons are shown over here like this. In this process 3 more neutrons are ejected. Let me show those 3 neutrons as 3 and 1 to the base naught, and this will again show you 3 neutrons, 3 and power 1 to the base naught, right? Now again this neutron is fallen and naught 1 and this and 1 naught, like this is 3 same neutrons. Again this is same neutrons, 3 neutrons. Okay, this is same neutron. Okay, again each neutron produced over here will be fallen on separate uranium-92 to 35. Look like this, 92 to 35. This is again fallen 92 to 35. Again uranium-92 to 35. Uranium-92 to 35. Again uranium-92 to 35. Again, and similarly this process carries on. Uranium-92 to 35. Uranium-92 to 35. Similarly 92 to 35. Okay, now for timing it will turn to an excited state over here like this. Uranium-92 with star on that 236. Uranium-92 with star 236. Similarly uranium-92 236 star on it. Uranium-92 236 with 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 star on it, and again uranium-92 236 with star on it. Similarly uranium-92 236 with star on it, and then each uranium-92 star on it 36 will convert into barium and krypton like that. This is barium, this is krypton, and again 3 neutrons are ejected. This is barium and this is krypton, again 3 neutrons are ejected. This is barium, this is krypton, again 3 neutrons are ejected. Again the same process, barium and krypton, and again 3 neutrons are ejected. Similarly barium and krypton with 3 neutrons are ejected. Similarly again barium and krypton with 3 neutrons ejected. Similarly barium with krypton and 3 neutrons are ejected. Similarly here barium, krypton with 3 neutrons. Similarly this barium, krypton with 3 neutrons are ejected, and similarly this process carries on. You can see the diagram in book also, right? You can see a very detailed diagram in the book also. I have drawn it on the board also. So I have shown you how to draw this diagram. Do remember in book the diagram is shown till here. In book the diagram is shown till here. यहाँ तक book के अंदर diagram show है. Look, till here the diagram is shown. Till here the diagram is shown in the book. यहाँ तक this step, यहाँ तक this whole is shown in the book. This step is not shown, so you have to do this step also in the examination, right? So this is you will do in vertical form. So you will turn the paper and you will do it in vertical form, very detailed. Okay, you can see this diagram it's very clear and very easy to understand, right? So This was all about nuclear fission and fission chain reaction. Let me summarize today's work. In today's work, we have defined nuclear fission. We have defined that the splitting of parent nucleus into daughter nuclei with emission of 3 neutrons and huge amount of energy, what we call nuclear energy, known as nuclear fission. And this process was carried out by falling slow moving neutrons, and it was initially absorbed inside the nucleus, and uranium was turned into an unstable excited state for a period of 10 power minus 12 seconds with atomic number -2 and atomic mass 236, and carries on, and further it splits into barium and krypton and again forms 3 neutrons, and similarly process carries on over here. And a very detailed diagram of this nuclear fission chain reaction or fission chain reaction is discussed in this lecture. You can read the book, you can read the book read the things from book, right? Understand the diagram from the book, and this is your home task to understand nuclear fission and understand fission chain reaction, and also write in your neat notebook, right? This is your home task. You have to, reading is also your homework. Reading from the book of the mentioned topics is also your homework. Like these topics, like whatever topics we teach you in video lecture form, you have to read those topics in home, right? You have to read those things, and if there comes problem, if there is any problem, you can share with us, right? Okay, so this is how we do with that. So this was all about today's lecture. Hope you have enjoyed the lecture. Thanks for watching. Allah Hafiz.